One of the very useful scenario for loop is running total. Running total is what we call a time series event, which means certain events happening over a period of time in the series. For example, if you have a pizza shop, your customer keep on coming, you keep on making sales. Each transaction is an event, which generates a sales amount. So from a data perspective, it's a series of data sales data along the line or along the timeline. At any point of the timeline, you can always calculate the total from the beginning of the day till the time of totaling. And as you have more transactions coming in, your total will become bigger and bigger. This is called running total. And in a computer program, this event can be simulated by user input. So your program may be waiting for user input. As users enter one transaction amount, you add this to the sales, to the total sales. Another input, you add this to the total sales. Another input, you add this to the total sales. At any given time, your total sales variable always store the total amount of the transactions that has been entered so far. So in this case, user event, each user event is a each user input is an event, and this event happens over time, forming a time series, and your program will perform a running totals against this time series. A time series can be endless, so we always need a starting point. At this starting point, the total will be 0. And we always need an ending point. And this ending point is determined by some condition. And that condition will determine the logic of your Boolean expression. So let's take a look at the total sales Java code. The total sales Java code, basically you have the input. Here, what's happening is you are going to determine the number of days. And for the number of days, you will be adding the value to the total sales. We start the running total sales, the running total calculation, by defining the total as 0. At the very beginning, it's 0. Then for each day, we add the sales to total sales. And this calculation will only be performed for the given day amount that the user input. If you input 7 days, that's a weekly sales. You input 30 days, that's monthly sales. And you input 365 days, that's a yearly or annual sales. That's a total sales calculation. And each sales, each day, is an event in the time series. In this time series, we simulate this time series by getting user input for each day. By getting user input for each day's sales. So you will be running this, and let's say I'm going to, how many days? Let's put it simple, 3 days. And first day, I have a sales of 100. Second day, I have a sales of 150. So far, it's 250, right? And the last day, let's say 200. 200 plus 250, I should get 450, which is what I get. This is the meaning of running sales and running total. And in this particular example, we are using a total amount of days. We know how many events are going to happen. Because we know how many events are going to happen, we know this is a counted loop. We use a for loop for this purpose. Now, okay, let's see how this is happening. So this is in general, you need to start by setting the accumulator or total sales or whatever total count into 0. Then starting the loop, you will keep on getting the next number until there's no more number. The key here is how do you define how many numbers do you have? In the previous example, we enter the number of days first, or to be more generic, we enter the amount of events, the count of events first. So we know how many things are coming, and we will use a for loop. But sometimes you do not know how many events will be happening. In the morning, you open the shop, you don't know how many customers are coming today. What are you going to do? One way is to have a prompt. Every time you read the next number, add the number, you will tell computer there's one more thing's coming. So you will have a prompt, another logic here saying, oh, there is a user inputted a yes for more transactions. So I'm going to go to another loop. If the user enters no, then I'm going to exit the loop. We already seen this in the previous example of repeating. After the transaction, you ask the user whether they want to repeat or not. If the user enters Y, then you keep on repeating. If the user enters N, no, then you exit the while loop. This is one way. Another way is using what we call a Sentinel value. Sentinel value is a signal. It can be used to notify the program to stop acquiring input. If it's a user input, the user could be prompted to input data that is not normally in the input range. Let's say there's no such thing as a return in your pizza shop. Once it's sold, it's never returned. So there will be no negative transaction in your transactions. Then you can use -1, which will be the normal input, as the ending point. As soon as computer sees the -1, they know they should end the program. This is called Sentinel value. Programs that get file input, you can also use the end of file marker to stop acquiring data. So let's see this soccer points data. Again, it has a while, right? While points, you are basically getting the points, next int, getting the points, and the soccer point cannot be -1, right? So if the minus points becomes -1, apparently that's a signal that the while loop should be end. That's a Sentinel value that we are using here. Otherwise, if the point is not -1, which means it's a valid point, or maybe even 0, it could be a valid point, then you add the point value to total point and keep on getting the next points. That's how you use Sentinel value. And sometimes it is also possible to embed a loop inside another loop. If a loop is nested, the inner loop will execute all of its iterations for each time the outer loop executes once. So what's happening here is, for first loop, I equal to 0, this J loop will execute 10 times. Then after J executes for 10 times, the I loop finishes its first iteration. It will start next iteration where I equals to 1. Then the J loop will execute another 10 times. So I loop will execute 10 times, and inside each I loop, J loop will execute 10 times. So in total, it will execute 100 times. Let's see the clock.java, where you can see hour execute 12 times, and the minute execute 60 times, and second execute 60 times. And if we just keep on running, it goes all the way to 12:59:59. From the very beginning, I believe it's, it actually go beyond what our console can contain. But yeah, it starts at 01:00:00 and all the way till 12:59:59. Sometimes you may also want to break out of loop without verifying the condition Boolean expression in the loop structure. It will be an unexpected break. For example, if you keep on adding things and your value exceeds certain amount, certain threshold, you may want to break out, right? The break statement can be used to abnormally terminate a loop. The break statement will stop your current loop and start the execution at the statement after the loop. The use of break statement in loops bypass the normal mechanism and make the code hard to read and maintain. It's considered bad form to use the break statement in this manner. However, there are times when you need to use break, especially when there's a exception, when there's some unexpected things may happen. Similarly, we have a continue statement. The continue statement will cause the current execution of a loop to terminate and the next iteration will begin. The difference between break and continue is break will going outside the loop. Continue still keep the loop, just starting the next iteration. So if I have a I loop, I from 0 to 10, from 1 to 10, and when I is 5, I have a break. That means I'm going outside of loop, starting from the next statement after 4. I'm not going to execute anything inside the loop, for loop anymore. But if I use a continue, I will start from the next iteration, which means I equals 6. Then I will continue with 6, 7, 8, 9, 10 until the loop finishes normally and exit. So continue will cause the evaluation of a condition in while and for loops and force it to run. And like the break statement, continue statement should be avoided because it makes the code hard to read and debug. So we just briefly mentioned break and continue. We will have one question in our homework assignment on break and continue, just to show you what is available in your tool set. But in general, try to avoid break and continue. Now, we have 3 different loops. Sometimes you may need to determine which loop you want to use. You can have the while loop, which is a pre-test loop. Use it where you do not want a statement to execute if the condition is false in the beginning. Versus do while. Use it where you want the statement to execute at least once, then evaluate. And for loop. For loop is widely used where there is some types of counting that can be evaluated. This is the most typical use of all these 3 loops.